Again, the purpose of heating is to bring temperature up inside your house. Again, you see the PowerPoint has a small verbiage and a lot of pictures. Just try to make you remember. Temperature difference, that's actually a good one. I like that one. How do you get temperature between inside and outside? I got several questions about that. When we did our house, what is the outside? The feeling Springfield is 0. The inside is whatever you want it to be. Between 65 and 75. Usually you want the house to be at night around 65, 60. Actually, there are some documents from the National Sleep Institute that if you sleep in a room that's higher at 72, you're not going to get good night's sleep. So it has to be a little bit cooler, so between 60 and 65. So that's the temperature difference for heating. For cooling, it's going to be the opposite. It's going to be summertime, 90, 120, and so forth. What is heat loss? What is heat loss?
Loss of heat.
From the house to the outside, because there is temperature difference. There's no temperature difference, you're not going to lose heat. What causes heat loss? Temperature difference and the lack of insulation. How is heat loss measured? BTU hour. What affects the rate of heat loss? What is the equation? Somebody.
Q
times delta T.
A times delta T.
U times
W times.
So what affects the heat loss? The area exposure, the material or the insulation, and the temperature difference. Those three are the factors that affect the heat loss. There's going to be a question in the exam about that.
Yeah.
Okay, heat loss, two things. There's gonna be a question in the final. I keep asking this all the time, and all the time people mess it up. We lose heat through two things. Infiltration, which means air exchange to outside, holes, openings, and transmission. Transmission through solids. If I lose heat through the wall, that's transmission. And the reason you have to focus on both, come on guys, the reason you have to focus on both is because they're both going to add up to your heat loss. If you only did transmission, you did insulation, you did everything, and you're still losing heat, what's going on? You're losing air. Air coming into the house, or air is leaving the house. Transmission losses, heat transferred through confining wall, glass, ceiling, floor, and other surfaces. So this is verbatim description from Ashbury. I'm probably going to ask you what is transmission losses. So the question will be like, transmission losses is, I'm going to give you this answer and some other not a lot of sense answer. But again, read the questions very carefully. Do not read the first one, oh, that's it, and you check it out. Read each one of them. And again, the key about this exam is just relax, take your time, get coffee. It's very long, pace yourself, create some notes, and a calculator and scratch paper. No notes.
Yeah, I thought I heard. I was like, notes, huh?
You can take notes from the questions. Some of the questions answer each other. So you find-
That's what
yeah.
you're saying.
Yeah. Infiltration losses. Energy required to warm outdoor air leaking into through the cracks, crevices around the door, windows, or through open doors and windows, and through porous building material. Make sense? It's really not that complicated. Transmission losses. Why do you wear coats, scarves, and insulated material? Yeah, to contain the heat, because you're producing heat. Same as the house. You're producing heat in your house, you don't want to lose that heat. So that's why you need to insulate, and that's going to be transmission. Human body creates heat. How much heat do we create? Around 500 BTU per hour, around 100-watt light bulb. So you're making your own heat. Luckily, we are warm-blooded creatures, so we make heat. Otherwise, you have to hibernate in the winter. So most mammals are warm-blooded, so you make your own heat, which is good. If you insulate that heat, then we're doing great. We can start keep it contained. How much does the human body generate? It depends on the activity. If we're just sitting in the classroom here, probably it's around 100 watt. If you go in the gym and do cardio, like running, or use an elliptical machine, your kilowatt hours higher. It's intuitive. An office worker is estimated to give around 500 BTU hour. So you're sitting around and doing much, that's 500 BTU hour. As a light bulb, 100-watt light bulb. Questions? Where does the heat go? Cooler places. Heat goes from hot to cold all the time. Cools on your body, which is like the air. Leaves the direct to earth, the temperature difference between the body and the surrounding environment. This is the rate. It depends on the temperature difference between your body. What is the body temperature? 97. Right? 97. So if the outside is 0, that's a really large temperature difference. So depending on what is the exposed area of your body, your hands, your face, or whatever, you're gonna leak from that. Also, the insulation material. There is no insulation in your skin, bare skin. Once we lost our hairy bodies during evolution, we had to deal with two things: the sun and also the heat. Yeah. So, and there was an advantage actually to losing. If you want to watch, there's a good documentary called "The Story of Us." It's pretty awesome. The evolution of us is pretty interesting. But anyways, so you lose heat to your body, so that's why we cover up, and the surface area, you lose a lot of heat. No protection, any heat, oxygen is transferred immediately to the surrounding cold. If you're not wearing anything, and if it's -10 outside, this is the envelope around your body. It's gonna be -10. Whatever heat you have, it's going to be leaving quickly, and that's air. What if why do you get hypothermia? You heat too fast. Your body cannot generate anymore, and it shuts down. When you take a dive into cold water, your body loses heat very quickly because water is very conductive, unlike air, and your body cannot regulate its core temperature, which is the temperature at your liver. So it starts to freeze, and that's when you stop going to hypothermia, because your body cannot generate anymore and cannot keep up.
What would they do the ice bucket shower?
Huh?
You know, the ice bucket showers. So
I don't know. Probably they're very hot, man. This is the only bucket. They don't drop you in a freaking river, ice water. They just pour it on you. Probably you're hot already.
Yeah.
But if you take a dive, if you take a bulge in the ice water, probably if you're not trained for it, you'll go into hypothermia. Some people can, and again, it depends on your body mass, how much insulation do you have. If a big person with a lot of body mass can not lose as much. Not necessarily, man. Some warriors are not fat. Have a lot of body mass.
If you throw a bodybuilder in there, he's gonna react a lot quicker than a fat person would.
Maybe. I don't know. Fat is very insulating, by the way. Yeah. Building little bonds around yourself. Probably you've seen that about tents and people try to survive. Again, the idea here is like you lose body temperature quickly. Draft. So we're talking about that was transmission. What about draft? Draft or draft? Draft. What is draft? I don't know what's draft.
I think he's just saying, damn, like,
Yeah.
Damn.
It leaves faster than your body ability to generate. If you have a lot of air coming through you, probably it will make you lose heat fast. You add source of your space, temperature goes up. Again, we're talking about small envelope, small area, and you can keep that space with whatever you have. I don't think a candle will do. You need small heat source. Well, if it gets too hot, you want to again to transfer the heat outside. Same idea. Just keep going over and over again.
This was made by the company.
Yeah.
They need to hire a new guy.
I felt really good about my PowerPoints because I made it myself. I look more professional.
I know. Fine, you set our expectations too high.
I know.
Yeah.
This is from the ESCO Institute, man. I was expecting something more like. But I guess they want to make it entertaining. They want to actually.
Yeah, or slides, I mean.
We got your new job.
We'd like to have me. Let's put it this way. Look, really? This was $200. It's like, really?
That was $200?
Yeah.
You overpaid.
I know, it's okay. That's half. And they don't let you know what's in it. You have to buy it. Okay? Probably has all the stuff.
They don't give like
So go through it.
participation.
We did talk about the cup of coffee and all this kind of stuff, that cup of coffee will lose a lot of heat in the winter than in the summertime. Ice. Heat gets from hot to cold. And direction. There will be a few examples where they give you a temperature inside, outside, and ask you for the direction. Temperature difference, and where does heat go inside to outside, outside to inside.
Wow.
Whoa.
There's the $200.
Just run it all again.
Heat goes to cold at a rate relative to the temperature difference. Does that make sense? The equation here. You making a noise or was it? You came with it.
No, that was.
No, scared.
Oh.
That was me.
Actually, that makes sense a little bit. It's kind of cool because how fast you lose the heat.
So is that what's supposed to show, like how fast?
Yeah.
I don't think it goes that fast.
1 mile per hour is
Let's go again.
We're in school, so we can't really.
Bro, stop making it sound like a zoo.
Sweet. This is actually interesting. But we did that path of least resistance. So if you have, we talked about the thermal bridging and the window, and usually use more heat from the frames than the glass. Did we talk about this enough already? Conduction, solids, convection, fluids, and radiation through anything. So,
Say water.
solids. It's kind of nice. Come on, it's worth $100. Thermal conductivity,
What is that?
conduction. Hey, what is that? That's somebody's
It looks
frying
like an
some.
egg in a fan.
It's frying food.
Throw it into a box fan.
Conduction, some conduction solids.
Didn't even de-shell it or anything.
Poor conductive material, fiberglass, foams, metal wall. I remember one of the questions asking you, giving you a material, and they will ask you which one is a bad conductor and what's a good conductor. Thermal conductivity. Did we talk about this? Week 2, probably. And I told you don't need to know what is the value, how it's calculated, but you just know it's a property of the material. We talked about also the length. I should sell my PowerPoint somehow. Let's put it in this one. Good point. Conduction also happens in fluid as well as solids. So if you have a fluid, flow will conduct heat through it, but also as it moves, it will do conduction. Okay. Lava. Convection is the water boiling in a pot. Convection. This is something we talk about a lot. Free and mechanical or forced. So free is an example of the radiator, placing the radiator to the roof. Forced is when you have a fan or a pump. Dave. I'm just jealous because you guys are laughing. That's you know. I want to be a student instead of with them.
Yeah,
Come over here.
I think this is the focal point over there for the fun.
Mirror.
Actually, when I used to be a guy, I used to sit where cows sit all the time and harass the teacher. So this is my bad karma coming back to me.
Oh, yeah. That's what you get.
Convection, yeah. Free, natural buoyancy. Hot air rises, cold air sinks, forced. These examples, by the way, is going to be, I see some of them in the quiz. I mean, in the exam. Ceiling fan, is this forced or natural?
Forced.
When you have, if there's a fan, it's always going to be forced. If there's a pump, it's going to be always forced. Same idea.
Wait, were you talking about drafts?
Huh?
We're talking about drafts with a fan, right?
Yeah.
Bill taught us that only if a fan is at the start of a furnace, it was forced, but if it was like in the middle, it was Yeah.
Induces after and forces before.
Yeah,
That's how he explained it.
yeah,
That's a good actually way to put it.
yeah.
Induced is you have already natural and you just push through.
Yeah.
The beginning is forced coming out of the furnace, but if you're in the middle, that's induced. But it's not natural. Buoyancy, the idea. I think we did that a few quizzes. What is this?
What?
What is this? What is it supposed to be?
Amazing.
They had to pay that man.
Feet power instead of horsepower.
That's the guy
Touch it.
Hey, would you like to be in the PowerPoint?
You ever tried to?
I want my money back. I want my money back.
Yeah, I would take the money.
Pictures, say, what the hell is this?
That was me actually.
Took the picture?
Natural convection, forced convection, radiation, electromagnetic energy, wave. So everything that's hot will radiate. We are radiating right now again, and every hot object has all modes of heat transfer. Remember that. But which one is most dominant? Again, now I'm conducting through my shoes, the floor. There's convection, natural around me, and there is also radiation. I'm radiating to a cooler temperature. Travels outward from the source, straight lines at the speed of light. So straight lines. Does radiation require a medium? No. It goes through vacuum. It cannot bend straight lines, of course. That's why you see a lot of dish apparatus to send lights, radiation. Of the three methods of heat transfer, how does solar energy get from Earth? We're 5 years old. I mean, come on. Okay, exercises.
Oh,
What is the cat heat transfer to the radiator? That is sad but true.
Yo, orange
That is
chicken.
sad but true. Heat transfer from the cup to the room. Most dominant.
China has an annual dominant.
Eight dogs,
Yeah, but it's
Natural
most of
forces.
them aren't actual. Kind of raccoon.
Heat transfer from the bottom to the ground. Conduction. What about fire? Huh?
Convection.
It has natural convection. What else? When you're sitting, let's say I'm far from the fire, radiation. Because the air is going out, the heat coming to you is radiation. The convection is through the air. What about this one?
Conduction.
From where to where? If you were talking about from the pot to the water as conduction, what about from the water itself?
Convection.
Convection, natural convection. The hot water will rise and circulate. Around the whirlpool. I'm not buying a whirlpool. Brownies baked in a glass pan using 2 methods. What do you think? Yeah. Conduction and convection. And up the pan to the cookies, the brownies, and
Well, don't you have the name of the
Oh, you were right.
I was wrong.
You were right.
Yeah.
Convection from the fan.
Well, I'm thinking of the heat lamps that are in like a stove or something.
Well,
Yeah.
This is bogus.
if you put them in an oven,
Yeah.
Okay.
I microwaved it.
You're gonna microwave.
Okay. Heat in the room moves from the warm current from warmer area to cooler area.
Also natural
convection.
Who says convection? Yeah.
I just put it in a glass.
You feel the heat of wood stove when you stand next to it.
You feel heat.
See? Got it. Warm water rises in the lake, cold water descends.
Convection.
What's this conduction?
Conduction. I'll go with that.
Huh?
I'll say, I'll go with conduction.
Who says convection? Raise your hand.
I say convection.
Who says conduction? Why?
I don't know, because they're touching and they go, why?
Convection. Convection is
I
when
like to
the
stand out.
convection has to do with fluids, and the hot thing goes up and the cold comes down. A thermometer under your tongue shows that you have high fever. That's conduction or convection or huh? Which is conduction? I said it's conduction.
So are these gonna be like the questions on the
Yeah.
test?
Yeah. Similar, something similar. I'm not sure like you. Sun transfer its heat to our planet.
Radiation.
Our planet. On a cloudless line, the heat escapes from planet and goes into space.
Why is it characteristic cloudless?
I think it's trying to confuse you. It's radiation. Space is empty.
Wow.
Got it. Oh.
Radiation.
Huh?
Radiation.
Conduct.
A thermos bottle has a shiny interior. What type of heat transfer does it prevent?
A.
Shiny.
C.
A.
No.
Shiny. What is shiny?
Radiation.
Radiation. Reflects.
Oh.
Who gets stopped?
Sorry, I'm triggered.
This is kind of funny. How is heat loss measured?
I was thinking that's the question, the answer's right there.
That's the whole section. There's gonna be 25 questions about that nonsense.
Okay, we can look at that section.
Okay. Wednesday, why don't you just go over it by yourself? If you have any questions, let me know. I think you can finish in 1 hour. Just sit and skip through it. Wednesday we'll do the project. Friday the quiz. And next week we'll do the.
Removing the.
I feel like